wing of an organization? I'm not, like I said, I'm not familiar with your organization, or maybe a couple of different organizations from what I've seen, as our folks in the UK might have been.
Yeah, so it's competition between universities across the world. Originally started between a couple in the US, and then as it got bigger, it became into its own foundation called the iGEM Foundation. So the International Competition for Genetically Engineered Machines, and each university that wants to participate, depending on the professor that is in charge of that university's team. So normally, like the life science department or biochemical engineering department, for our case, they choose the team. So we're part of UCL as students, all of us. But we're sort of just competitors within this iGEM global competition.
Okay, all right. Okay, I get it now. Okay. So are you then looking for, are you looking for an actual participation from the desal facility in Carlsbad?
We're mostly looking just for like advice on the actual implementation of the technology that we're proposing.
Yeah.
Oh, okay.
Yeah, as one of our purpose, we are gonna like propose the real world implementation of our project, and as we know that Carlsbad has already launched its own desalination plant. So like we want to seek for some suggestions from you as an expert's perspective on the implementation parts of our project.
Yeah. So the plant in Carlsbad actually has been operational for a while now. Well, I would say a while, a few years, maybe I want to say maybe 7 or 8 years. And you know, in the US, it's very difficult to permit and construct desalination facilities because of environmental concerns of extracting the water from the sea and then also discharging the brine. And a lot of the issues with the desal plants are not so much related to the technology, but related to how they pull seawater out and how they discharge the brine, and what sort of intakes they use so they don't harm the biology. California in particular has its own ocean plan, which makes it even more stringent and difficult to do desal facilities. So Carlsbad, so far, when it started, it was the intake that they used was something that was, I believe, already in place, because it's next to Encino power generation facility. So they used their intake for years, and then when the power generation plant finally phased out, they sort of had to get their own intake. So most of the time, because of the energy usage, obviously, like they are in rest of the world, the desal facilities are usually next to a power plant. So the same company that developed the desal facility in Carlsbad is now attempting to do, they actually sold the Carlsbad plant to Aberdeen, I believe, and although the operator remains the same that they had before, I'm drawing a blank on what their name is. It's a firm out of Israel that does operations and is very well known in desalination. But they're also attempting to do another plant further south, or rather further north, and it is in Huntington Beach in the Los Angeles area. The biggest, I think, issue is with the power usage, which drives the cost of the water up. And they've incorporated in the Carlsbad plant the energy recovery that I think is able to power maybe 30%, 25 to a 30% saving. So, and that's, I mean, at least that's where I think that's how far sort of the energy side has gone, and maybe a little bit more than that around the world, maybe 50% or so. But energy remains to be the most critical, sort of expensive feature. and drives. I think the more you can save on energy, the cheaper obviously the desal water becomes, and the better it is for that to be a technology then that is used, right, everywhere in the world. Otherwise, as of now, the water produced by Carlsbad is about twice as expensive as some of the other water that is produced locally. Although when the plant, I believe, is run at full scale, which is about 50 mgd or so, at that point, the cost of the water becomes similar to their imported water. So all this is in Southern California, which has a shortage of water, and they get imports from Northern California, so it's pumped all the way down, like 400-500 miles down there. So obviously that it takes a lot of energy to pump the water down there. So that's sort of the overall. Sorry. Go ahead. Sorry.
Yeah.
Sorry. I was just say that it sounds like the.
So you went back on mute.
I think, yeah.
Pedro.
So it sounds like you were saying the power intake needed for that kind of desalination is the biggest issue with it. So assuming this proposed technology that we're working on is possible in the future, and that this comes with a lot of energy saving issues due to not having to press, obviously, the water using pressure, reverse osmosis using the pressure, would you say the main power problem is from the actual creating the pressure to create reverse osmosis, or is it the pumping of the water and intaking it from the sea?
It's the reverse osmosis process. The pumping is also a significant component of water usage, but it's really the RO process that drives it. And over time, as the membranes have become more efficient, the usage has come down a little bit, but it's just that the pressure that's used to drive it is where the largest horsepower pumps are still.
Okay, well that fits quite well then, because we've got most of our questions. We prepared a few questions to ask you, and most of them are to do with less to do with the energy costs, given that our technology hopefully reduces these significantly, and has more to do with like the practicalities of the brine and other things that you mentioned. So would it be okay to move on to these questions just quickly?
Sure.
Yeah. So thank you, Pedro. So our first question is, besides seawater desalination, we are also considering desalinating the brine system that didn't go through our treatment. And do you have any advice on the criticality or technical challenges of this?
Well, I would say that's depending on what your results are. That would be another place, obviously, that would be, I think. Let me see, a good maybe first step if you are concerned about having E. coli and other bacteria in it, and the water then presumably not being fit for consumption, right, human consumption. And I think there's a wider application of your product if you are looking at just treating the brine, because it's also not just seawater desalination, but a lot of other advanced, even wastewater treatment facilities that have an issue with brine discharge. So in Southern California and in like all of, I would say, Western United States, well, not all, so a great part of the Western United States, there are, because of water conservation, wastewater treatment plants that also have advanced treatment for recycled water for either direct, well, we haven't really got to direct potable use, but indirect potable use, right? And so they also end up with a very large quantity of brine and face a lot of environmental issues when they have to discharge it. So I think that would be a very good fit for your technology if it's successful.
Yeah, I think so. Yeah. And you said, and I've done some research on Carlsbad that, so you basically use our membranes to desalinate seawater. And I wonder, like, how to pre-treat seawater, or actually do you pre-treat seawater before pumping the seawater into for the membrane treatment?
I believe so. At the Carlsbad plant, there are pre-filters, and they go through and that's there's a pre-treatment process that removes. I believe. Let me see. There are two steps. There's a pre-treatment with just conventional filters, so big, giant sand filters, and then there's also a step where it goes through. Uh, a screening type filter, and the issues there are that if they wanted to expand, for example, that facility, they would be limited by the pre-filtration because it takes up so much space. And in an existing plant, for example, or any plant which is in an expensive kind of real estate location like California, that does become a limiting factor. So a pre-treatment process that's compact, which I'm assuming if this is compared to a conventional filter or automatic strainer type filter, would also be a good application.
Yeah, but did you come across like some issues of membrane fouling? Although you pre-treat your seawater, with membrane fouling, how would you treat how would you dispose or clean your membrane if you come across membrane fouling?
Yeah, I'm not really sure what they do, but they're in membrane plants here are often susceptible to fouling. It's two factors usually. If there is particles in the incoming water, and then the other one, which is really bad, is the algal blooms.
Mm-hmm.
Right, so they've had issues with both in at the plant, and had to shut down the facility for prolonged periods of time to be able to deal with that, to clean out the membranes and put them back into, I'm not sure, different kind of chemicals, and to be able to recover them to be back to where they're supposed to be, and in that period they're not able to produce water.
Yeah, definitely. I wonder if you can see my slides again. Yeah. If you can see our slides in the MDC, we are proposing to use this ion exchange membrane, which sodium and chloride ions would pass through the membrane into cathode and anode respectively. So, do you have any suggestions on how can we clean these membranes if they get fouled? Carlsbad has any experiences of using ion exchange membranes, or it is mainly using our membranes?
I believe all the membranes there are RO membranes. Yeah, I'm not quite sure how you would clean these. I don't have experience with that.
Yeah, thank you. And let's move on to our next question. So how can we ensure safety of the desalinated water? So from the perspectives of post-treatment, distribution, and storage. So you can see our proposed implementation strategy here. After the MDC, we usually do We usually do disinfection, or here we can follow using our membrane filtration to remove our GMOs from our desalinated water to ensure its safety. So from your perspective of post-treatment,
so two really main important points. Post-treatment are obviously disinfection. You want to make sure that it's disinfected to the regulation requirements, and there is if you're using chlorine, for example, or if you're using UV, which is also great, but also high energy consumption, that there is residual chlorine in there to make sure that that there is no regrowth, for example. And then the second thing that you have to be careful about, I don't know what your process does to the pH of the water, but there are two big concerns for RO plants are that they do have to bring the pH back to more neutral. Otherwise, a lot of plants have caused issues if that's not done right with the piping and impacts to the distribution system. Yes.
Thank you for that. Just a quick question: are these two issues more pertinent if the water is to be used for drinking water? Does it, the fact that we're proposing this initially be okay for irrigation as well? These have to be the same.
It would have to be the same. So the disinfection so I take that back. The disinfection would probably not be the same for irrigation, right? But it's better if it is close to more drinking water standards so that you're not exposing it. But irrigation, you do use wastewater, right? Recycled water. But it is treated to be pretty close to almost nil on total coliform. But the issue with is really with if you guys are all students of looking at the Lang-Lyers indices, right, of the water, making sure it's the ionic balance is back to so it doesn't corrode the distribution system, because there are going to be various kinds of pipes in the distribution system. So you want to make sure that your water is not abrasive, or in a lot of times there's the desalination water that was not brought back to the pH did was impact the lining of the distribution system pipelines, and basically just took away the lining in a few days of use. So that would be an issue whether you use it for irrigation or not. So do your calculations on your ions.
Yeah.
Would that be any metal ions and, for example, hydrogen ions that change pH? Both of those things.
Yes.
Yeah, and would that also be an issue for the brine? So basically, how would you treat the brine to ensure it is not disrupting the marine life?
Yeah, I mean, if you're discharging the brine, they're really just looking at the saltwater content. Obviously, you wouldn't use a very high disinfection dose on that, but it's just the TDS that they're looking at. They're looking to discharge it at the most dilute levels possible, or rather the levels that meet with brine discharge. It's the quality of the water, right, that's being discharged that should match the actual seawater, the water quality there, right? So they wanted to mimic that as closely as possible. They want the temperature is a big concern. They want the temperature to be cool. So most of the RO plants will end up diluting their brine to discharge. So there's a big dilution factor before it goes in there. And then how it is discharged is more of a question that it's a diffuse discharge. You're not really concentrating the brine in one particular area where it might then affect sea life. So brine's a little bit more, a different set of sort of concerns with brine, including the temperature. Brine, so go ahead.
Yeah, you said that, and as well was important. Is this dilution to be done with other water that maybe isn't high enough quality for irrigation or drinking water, and then this can be released back into the environment?
Yes. What the Carlsbad plant does, I believe, is using some discharge from the cooling tower waters of the adjacent power plant.
Okay.
So it could be, it could be cooling tower water, right? Something like that. If there's a large industrial user next door that has water to spare, so it could be that. You obviously don't want to use drinking water for that. It defies the whole purpose.
Yeah.
And so when this dilution is put back into the environment, is this something that's taken far out into deeper seas than just the more delicate shallow waters, or what's the strategy for that?
Yeah, the attempt is usually to take it back as deep as possible, so it has more room to dilute and to discharge it in a more diffused manner. So normally as the outfall goes out, it would have diffusers all along, and there would be calculations done to see what that what the pattern is of the water as it spreads.
Okay, thank you.
Yeah, thank you. And since we are kind of short of time, I wondered. So we have last question. Do you have time to answer our last question?
Sure, go ahead. I just want to give me one moment. I'll just check my calendar.
Yeah, thank you.
Yeah, let's go. Keep going, please.
Yeah, thank you. So our last question is, what requirements should a new technology have to be feasible in the desalination industry?
Sorry, say that again?
Yeah, I mean, what requirements should a new technology have to be feasible in the desalination industry?
To be feasible, I mean, obviously it has to be able to be implemented on a large scale, either for the actual treatment, or like you said, either pre-treatment or brine discharge. I'd say any kind of chemical consumption would be the biggest driver. If there's any technology out there that results in less O&M cost, even if it is so like for any technology, if the life cycle cost of that new technology is better or equivalent with some potential environmental benefits, that's what would make it feasible. So if you come in and you say you're basically not going to be able to do it for less energy, or the cost of your implementation of your process is so expensive that there isn't recovery of that cost for a very long time, then it wouldn't be feasible. For the market to really be interested in technology, those are the things that they would look at.
Yeah. So you think energy consumption and cost should be considered when assessing the feasibility of our project, and these two aspects are the main aspects that we should consider.
Yeah, especially the place. I don't know what the energy costs are back in the UK, but here it's 12, 14, 15 cents a kilowatt, which is very expensive. So that's usually a very big driver. And also from the perspective of, just being a more greener world, and carbon emissions, etc., that come from, producing this energy. So there's so many factors rolled into energy usage. And then, of course, chemical, although compared to in a desal facility, the energy is the biggest cost, and then there's chemical consumption as well. So yeah, I mean, there has to be a financial benefit, right? That you'd be able to, and you could take basically any sort of other benefits and roll them into some kind of a cost, and be able to say, for example, if your process ends up being more environmentally friendly, what are the advantages then, right? Do the plants then have to do less testing, for example, right? And there's a cost saving from just having people to do that test and also doing the test, etc. So, there could be sort of those minor costs that could also be rolled into a more of a financial benefit.
Yeah, that's all questions from me. Thank you, Sheba. And any questions, guys, from your side?
Yeah.
I just have one more quick one about brine.
Mm-hmm.
So is there any space or any opportunity for brine to just sort of be dehydrated and create salt, or it's the only way it's dealt with is by massive dilutions and taken back out to the oceans?
Associated with desal plants, I believe that's the case, and it's more of a practical, I would say, way of doing it, because they're, like I said, a lot of the desal facilities are next to large power plants, and so the dilution ends up being a cost-effective and a practical way of doing it. But I'm sure there are facilities that try to recover the salt as well. And the only constraint there would be is this something that would require area? Like if you were to you to do it with just drying it, or if you would have a process that would basically do it in a smaller footprint. I think that would be a good, that'd be a good application as well.
Cool. Thank you very much.
Thank you. So just to follow up on that really quickly, since we are like our target is not only selling water from the sea, but also like brining water from, for example, ROs. So do you reckon it's possible if we just recirculate our briny stream back into our microbial desalination cell for the second treatment instead of it discharging it to the ocean again or diluting it?
Yeah, I think the most that you could get out of, I would maximize as much as you can the recovery. So if you were to put it back twice and that ends up in a better product, I think that would be a good application.
Okay, thank you.
I got one more final question. So from our desalination process with the MDC, we produce some byproducts like hydrochloric acid and sodium hydroxide. So could these be used, for example, for the cleaning of the membranes, and then that could save up on cost that you need to spend on chemicals?
Absolutely. Yeah, that would be excellent. I'm all excited about it. Sounds wonderful. So are you all students doing a master's or bachelor's? What are all of you studying? What are your concentrations?
It's about half and half undergrad to postgrad out of the 8 team members. But yeah, most of us are in the life sciences.
Okay. All right.
Yeah, me, Anna, and Lee are studying biochemical engineering.
Oh, wonderful.
Yeah.
Okay. All right. Yeah, if you have any follow-up questions, you can email me as well. And as you go through the process, if you want to have another call like we had today, reach out to me, and Darlene, my assistant, she can help us schedule something. Yeah. All the best.
Yeah, that'd be great. Thank you so much.
Thank you so much.
Take care. Bye-bye.
Bye.
Yeah, bye.
Bye-bye. Take care.